is from Ford Powertrain. So we talked about the NAM, we talked about the National Institutes for Manufacturing, and now we've got our customer, and that's Ford Powertrain. And his name is Mike Bastian. Mike Bastian is the Global Controls Manager of Ford Powertrain, where his mandate is to standardize the automation solutions for powertrain and specify the requirements for control systems. Ford has taken a very proactive approach, ensuring that they are prepared for the future and the connected manufacturing floor. He will discuss the challenges of applying standard IT security to the industrial controls environment and how his organization has adapted and overcome those gaps. So please welcome Mike Bastian.
Standing room only out there? I hope so, because I know 80% of my team is here, so I'm expecting applause and banners in the back and so on. So I'm here today to talk about really a journey that we've been on as an organization for a couple of years, and it's culminating in the final stages of addressing security in the industrial controls environment. So that's what I'm here to talk about, and we'll get right into it. So I put this slide together to talk about, like I said, a multi-year journey that really started in 2014. We're into 2016 now. It's actually started early or late 2013, but I put this JPEG on here with a ticking time bomb, and I got some chuckles out of people who have seen this presentation. But there's no question today, with the amount of technology that we're deploying in the control systems, Internet of Things, Industry 4.0, you need to have the security in the controls environment understood and addressed. And I'm going to talk to you today about how we met that challenge and how we worked with IT and operations to put us in a better place. So starting on the left-hand side here, we talk about an air gap. I think that people have believed over time that the industrial control systems have an air gap between the IT infrastructure. These days, that's just not the case. You really have to recognize that in the industrial controls environment, IT policy does apply. We fought it. We fought it for many years. There are individuals in this room that have kind of dabbled in language in our IT policy manual about how to protect industrial controls environments. But in reality, these days, the area is gray, but it's the gap between IT and industrial controls is closing. So back in 2013, late 2013, early 2014, we were starting to get into situations where our auditing function within Ford, the GAO, was actually going into our plants and starting to apply IT policy down into the industrial control systems. And it was happening hit and miss, and certain infractions were raised for violations, and it was gaining momentum. So as the external community was starting to pay more and more attention to cybersecurity, our internal auditing functions were starting to actually get deeper into the industrial controls environment. And what they were zooming into in the early stages was PCs. So you'll see some slides later on to talk about how much actual horsepower, PC computing horsepower, we deploy in industrial control systems. At any given plant, we're talking 400, 500, 600 personal computers that are down in the industrial control space. So the auditors, knowing computers are linked into IT, started zooming into those PCs, and actually we're taking language out of IT policy and saying, where's your virus protection? Where's your disaster recovery? Where's all the common IT policy stuff applied to these PCs? Well, it turns out they weren't applied. These computers were bought by manufacturing engineering, often not by controls, but by our process engineering community within production engineering. They would buy a PC next to a DC tool. They would buy a PC next to a vision system. They put it down as part of the equipment, part of the plant floor machine, integrated into the control system, but no sustainability plan on how to manage that PC going forward. And this is snowballed into a significant challenge for us. So this red box here, who owns the problem? Well, the controls engineers weren't necessarily owning the problem. IT certainly at the time was not owning the problem. The guys or the folks, the guys and gals that bought the equipment weren't owning the problem. So what ends up happening is nobody owns it. And as these audits were going forward and you know, IT policy was being applied to these computers, they were looking for somebody to hang this, this brick on. And they found me. And my team. So all the 60 guys around here that are part of our team are living this dream right now, because at the end of the day, it's part of the control system. That computer that's sitting inside the equipment doing certain functions is part of the control system. Who owns the problem? We do. And it's part of our control strategy going forward. So back to the next part here around compliance. So I want to talk a little bit about this to give the crowd here an overview of what type of IT policy applies to industrial control systems. The IT policy manual that we have at Ford, now called the ISP, which is the Information Security Policy, so the title's changed a bit, is a 150-page document. It's got all kinds of language and confusing information in it. I've read it. I've peeled back through it several times. Some of my team has as well. And I actually had a copy on my desk for a period of time with post-it notes in certain pages of the policy that I thought applied to industrial controls. And what ended up happening in the early phases of this is we had to get some alignment around what language in that document makes sense to push down into the manufacturing environment. And you have to recognize out of the gate that some of that policy makes a lot of sense and does apply. So certainly the global controls team is heavily involved in this, and we're taking ownership. We're standardizing our PC deployments. We're standardizing the software that runs on these computers now. But at the time, back when this whole problem started, that wasn't the case. So I put the number 7 on here because after taking you know, several different scans through the ISP or the IT policy manual, we recognize 7 areas that have to be addressed in the industrial controls environment on PCs and other intelligent hardware that we deploy. And one of the things that we've gotten the IT policy team and IT security to understand is that, you know, you talk about the word CIA. And I don't know, for you, those of you that work in this kind of a space, that will make sense to you. It's not the CIA that the government runs. It's around the classification of risk associated with assets. So confidentiality, integrity, and availability is the typical hierarchy that IT uses. So they're protecting personal information, protecting integrity of data, and then availability is the last area that they prioritize. Well, when you're in the industrial controls environment, you've got to switch that. You have to take a different, if you keep the same acronym, you just got to change the letters around. So in our case, in industrial controls and in our production systems, availability is the #1 issue. Those assets have to be available, they have to run, we have to be able to make parts. Then the integrity and confidentiality are downstream from availability. So we've taken the CIA asset classification and turned it around to AIC. And I've seen this in publications. It's not just a Ford issue. I think people are recognizing in general availability is priority when you're talking about manufacturing control systems and security. It is a recognized systemic issue. So this isn't a problem in one plant. I mean, we had Greg Sherrill up here talking about Dearborn Engine. Dearborn Engine is one of 30 global powertrain plants that we have. It's not just a problem in Dearborn, it's a problem in Livonia, it's a problem in Van Dyke, it's a problem in China, it's a problem in Brazil. It's a global issue and it has to be recognized that it is a global issue. So the 7 areas that we've aligned to as far as policy that's applicable to industrial controls are shown here. And every one of these circles, I could go into an hour discussion on each one of them. I'm not going to do that to you here today, but I do want to talk about these because it comes up later on in the presentation. So starting at the lower left, disaster recovery. So when you have computers that are deployed in industrial controls, or you have even controls assets, PLCs, CNCs, that type of HMIs, that type of thing, you have to have a disaster recovery plan for those assets. If that asset crashes, if you lose the hard drive on that computer, you have to be able to recover it, and you have to be able to recover it quick. So having a disaster recovery plan for devices in the industrial controls environment is a very, very high priority for manufacturing systems for continuing production and being able to meet our JPH requirements.